Good morning or afternoon or good evening, and welcome to OpenDev Containers in Production.
Hello, everybody.
Looks like we have folks signing in from all over right now. We have Beth on the East Coast of the US, and some people joining in from the evening. So welcome. This is our third OpenDev of the virtual series that we've been doing for the past few months. And Ashley, I can't believe this is our last one.
I know, Allison. It seems like it's been forever since our first one. These have been going really well. I think they've been awesome events, and I can't wait to see what the follow-up is like.
I agree. Yeah, we've had some really great discussions earlier this past few months, and we'll be sharing the recaps with those later. But for now, let's go ahead and dive into containers in production. My name's Allison Price, and this is Ashley Ferguson. We're from the OpenStack Foundation, and we'll be your MCs for today and tomorrow. Like I said, this is our third virtual OpenDev of the series, and the focus for today and tomorrow's discussions will be containers in production. And just want to emphasize, it is a 2-day discussion. I know that there was some confusion, but we have shortened it to 2 days. So just join us back here at the same time for tomorrow, and we'll kick off new discussions then. And our next virtual event is actually going to be in October. This will be October 19th through the 23rd. This will be virtual as well. It will be free, so registration is now open. You can see the link here, and feel free to go and register and plan to participate. And the CFP closed last week, but if you have speaking proposals that you didn't make before the deadline, please email us. We have a few open slots left, and we can work with you on some options. All right, and I'll pass it on to Ashley to tell you how to participate today.
Thanks, Allison. Yeah, so if you have been to any of our other virtual OpenDev events, you're probably pretty familiar with it by now, but just in case you're new here, welcome. Obviously, the first tool we're using is Zoom. So congrats, you made it here successfully. If you have any technical issues, let us know during the event. I'll let you know how to do that in just a second. And then the other tool that we're going to be using is called an Etherpad, and that's an open source collaborative tool, similar to a Google Doc, but open source. And so we'll have one Etherpad per session so that we can take notes in there and use that throughout the event. So back to Zoom, the first thing we'll be using in Zoom primarily is the Zoom chat. So if you have any technical questions, relevant to the topic discussions, feel free to drop those in there. We'll have the moderator and as well as other people from OSF watching to make sure we can answer as many of those questions as we can. But we also want to hear your voice and hear you jump in. So feel free to unmute yourself and actually jump into the conversation. That's what OpenDev is all about. We want it to be discussion-based primarily. So feel free to jump in when the time is right. And if you're not speaking, please try to keep yourself on mute just to cut down on any background noise. And then back to Etherpads. Like I said, this is a place for notes, feedback, action items. There are some questions and little polls in there that you can participate in. And there's also a designated area in each of these Etherpads to put your name and contact information so that people can connect with you after the event if you'd like. And then if you're interested in speaking during the discussions, put an asterisk by your name. That way our moderators know that it's okay to call on you and that you're comfortable speaking. And if you need any help at any time during the event, feel free to open or email events@openstack.org, and we'll have some folks waiting on the other end to help you with any technical questions or logistical questions. But like I said, if you have a technical question that's relevant to the topic discussion, drop it in the Zoom chat. We'll have people watching that. And then we also sent out a tips and tricks Etherpad in the pre-event email, so feel free to look for that. We'll drop that Etherpad in right now, and that should answer any other questions that you might have. And then I'll hand it back to Allison to introduce and thank our programming committee.
Thanks, Ashley. Yes, I want to thank the programming committee for this event. A lot of work goes into the weeks leading up to today to identify topics and moderators and get some discussion planning started. So a huge thanks to all of these community members who have spent the time to plan this week's event. I also want to thank our OpenDev sponsors. They make not only this event possible, but they make it free to join, and so everyone on can participate in today and tomorrow's discussions. All right, so I'm going to do a short little kickoff. And like I said, this is our third OpenDev of the virtual series and our fifth OpenDev overall. So earlier this year, we did one around large scale usage of open infrastructure and one on hardware automation. And we're going to throw those links into the chat now for the recaps, just so you can see what kind of discussions were had. And there are a lot of takeaways and outcomes that are resulting in ongoing work. So if you're interested in those discussions or they're relevant to the environments you're working with, please join those initiatives. They are still ongoing. I know the large scale SIG is actually meeting this Wednesday. So definitely check that out if those topics are of interest to you. But this week, we're going to be talking about containers in production. And when it came to choosing the topic, I think that containers was definitely top of mind because when we look at the growing market, 451, and Ashley, next slide. 451 anticipates that just the container applications market alone is going to be $4.3 billion by 2022. This is an incredible growth rate that they're seeing over the years. And when you partner that with OpenStack market, this is a $12 billion market by 2023. $12 billion. So there's definitely a lot of growth in both of these markets. And with that growth comes choice. Choice for different software technologies, choice for implementation strategies. So when looking at all of these different choices, it introduces integration challenges. And so when we talk to our users, we hear all of the different open source components that they're combining into their environments. And this is just a sampling of some of those technologies. And when you add more and more software, then you get more and more challenges sometimes. So here is actually a sampling of data from our very own OpenStack user survey, just to show that it's not just one size fits all. Every OpenStack user chooses something else to manage their applications based on what makes sense for their own environment. But so this is why we are here this week. You know, as you saw on the last slide, Kubernetes was, the leading choice for OpenStack users. So just last week on Twitter, we asked, who's running OpenStack in Kubernetes together? And we got a whole lot of answers for different companies that are running them together. And they're not all running it the same way. So even once you choose your technology choices, integration is still something that requires more additional information and choices for your team. So we see like Stack HPC and Tim Bell from CERN, they work with OpenStack Magnum, which is a component of the OpenStack software. And we have others that are working with Charms. And I think that Ann Harding actually asked a really interesting question because OpenStack and Kubernetes can be orchestrated in a lot of different ways. And that's why there's actually a topic for discussion today that is just about OpenStack integration with Kubernetes, because it's definitely a question we hear a lot from our users, and it's something that people have on top of mind as they choose to move forward with both of those technologies in production. Like I said earlier, coming out of the OpenDev events, one of our goals is to help the discussions this week and those previous weeks go into ongoing work. And I wanted to showcase some of the examples of that ongoing work that our community has been doing. So 2 years ago, the containers community with both Kubernetes and with OpenStack created a really comprehensive white paper to talk about those different integrations that users are doing in production. There's use cases from CERN and AT&T and quite a few others in this white paper, as well as architecture diagrams and just a lot of answers to the questions that we hear on a daily basis. So if you're interested in looking at that white paper, it's at openstack.org/containers. And if you're interested in getting involved in some of the work coming out of this week, stay tuned as each discussion may have different calls to action. Another good example of work coming out of the communities is the Baidu white paper that the Kata containers community published I think it was last year. Yeah, last year. So they detailed how they were integrating Kata, OpenStack, and Kubernetes, which is a really new use case since Kata was only launched 3 years ago. So here's another great resource and just a really good example of the kind of work that we're excited to see come out of the discussions this week to solve the problems that operators are having when deploying containers in production. So speaking of Kata, we actually have a demo for this morning. So this is around monitoring container usage. It combines a lot of the technologies I was just talking about. So to kick the event off, I actually want to pass it to Ben Liu and Shu Wang from Ant Global.
Hi, hello everyone.
you go.
I'm Xu. I'm Xu from the Kata Containers project, and let me have a short introduction. And I am a member of the Kata Containers App Committee, and we use the lightweight virtualization for the isolation of containers, and we are one of the open infrastructure projects of the OpenStack Foundation. And Kata Containers was announced in late 2017 and announced 1.0 in 2018. Right now, my team work for Ant Financial Service Group, and we already have thousands of production nodes that have Kata Containers running. Right now, we are working for the 2.0 and 2.0 of Kata Containers, and which will be released in October this year. And one of the main goals of the 2.0 will be the observability. And being from my team that's working on the observability and the metrics collection, and he will introduce this part today. Yeah, thank you.
Ben, I think you might still be muted.
Hello?
There you go.
Hello? Hello everyone. Good night or good morning. I'm Liu Bin from Kata Containers team, and I'm glad to show you a simple demo about metrics in Kata Containers 2.0. Before starting the demo, let me give a basic description about the metrics in Kata Containers 2. Here is the basic data flow. Before Kata Containers 2, Kata only provide CRI metrics interface. The metrics are container-centric and basic memory, CPU, network interface, or disk devices, and only for containers. As Xu has said, observability as one of the most important features in Kata Containers 2, and the metrics as the core part of the as the core part of observability and for running Kata containers at scale. Our demo is running in a Kubernetes cluster, which cluster will have only one node. All user workloads are running in Kata containers as pod. Kata monitor is used to collect metrics from Kata container D shim v2 processes. A dashboard of Kata Containers 2. Metrics in Kata Containers 2 contains all components of Kata containers, including Kata monitor and container D shim v2 process. And Kata agent that running inside the guest OS, and here is the hypervisor metrics. And the last, the guest OS metrics. Kata Containers 2 is using Prometheus protocol to expose metrics. Prometheus is a graduate project from CNCF and widely used as a monitor solution. So any tools that are compatible with Prometheus can integrate with Kata containers. And the Grafana server is an open source visualization platform. Now let's begin the demo. We have already some pods running in the Kubernetes cluster, so we can see a number of time series in the graph chart. In the Prometheus dashboard. Here this is a matrix that represents the running schemes count. Here we have 3 pods, so the number is 3. Let's try to delete or create some pods. The new pod named stress as running now. That we can, for example, we can see in this chart, we will have 1 pod here. The green one is stopped, and here is the new one as started. Then let's see an alert example. Prometheus has a has a alert function, and we can see all the alert rules and alert state using Prometheus server's web admin console. Here we have 2 alerts, and they are all in not active state. So all the alerts are in green color. We can go into the container by kubectl command. And we can use the stress command to simulate heavy CPU pressure. I'm also prepared a dashboard that shows the system load for the guest OS. Here we can we can see that this pod is start at this time, and the guest loss is increasing. It's now about 1. It's the alert value that we have set. You can see this as the alert rules. If the value is larger than 1, we will get an alert. Here, the alert will be triggered. Now the value is above 1. Now, after a certain time, in this demo, it's about 30 seconds, the alert will be triggered. And now it's in red color. Also, an alert message will be sent to Slack. Here is the Slack as the alert message that we received just now. Now we will stop the stress command. Then the guest load should be decreased. we can see that the time series is going down. And after about 30 seconds, the alert will be in normal state. And we will also get a alert message that indicating the alert has been resolved. Thank you. Above is the demo. Thank you for your watching.
That was great. And Ben, we actually got a question in the chat, or a few questions now. So I was going to pass some of those to you and Shu. The first is there a continuous data stream from the shim to the Kata agent to get the metrics?
Actually, we extend the agent protocol and get the information from the agent.
Okay, and the second question is, what's the size of the VMs with Kata containers and what operating system are you using?
Actually, for Kata, there is no full gas OS. We just use the gas kernel and some basic configurations to launch the containers inside the gas VM, and it's only provide the gas kernel space part and a small agent to monitoring and like supervisor things to maintain the life cycle of containers, and no full gas OS there. Yeah. And for the size, it depends on the configuration, and if you use the CRI protocol in the pod stack, there will be the limitation information that we will use this resource limitation info to create the containers, to create the pod. Yeah.
Awesome. Well, thank you both for that demo. It's a really great way to kick off today's discussions. And y'all mentioned a lot of the technologies that will be discussed later today. So I'm going to go ahead and pass it back to Ashley to tell us what is in the schedule for today.
Thank you.
Thanks, Allison. Yeah, so today we will continue talking about OpenStack and containers together. We're going to have 3 different sessions, and there will be an Etherpad for each session. And the first one, I will turn it over to Spiros to talk about OpenStack and other containers projects that are not Kubernetes together. And then after that, we'll have John from Stack HPC talk about OpenStack projects that interface with Kubernetes. Also, we'll talk about Metal 3 and Kata containers. And then the last session of today, we'll be talking about SIG cloud provider and provider OpenStack. And then tomorrow, our final day, we will talk about telco and network function, as well as security and isolation. And then we'll do a final wrap up for a good portion of tomorrow. And the wrap up is really key to these OpenDev events. So make sure if you're available to stick around for that. And we'll let you know how to get plugged in afterwards. But for now, I will turn it over to Spiros for the first session.
Hello, can everyone hear me?
Yeah.
Okay. So for this session, it was quite challenging to talk, since I'm also involved in the OpenStack Magnum project, for containers, but not including Kubernetes, but I will give it a go. So the main theme is that you have an OpenStack access. Okay, let's start first for me by a few words for me. So work in the CERN Cloud team. I work in the group managed by Tim Bell, which is in the board of directors, and in the same team with Belmiro Moreira, who is in the TC of OpenStack. And inside my team, I mostly focus on container integration with our infrastructure and OpenStack. And I'm a code reviewer in OpenStack Magnum, and I used to be a PTL for a few cycles. So for this session, the main theme is that you have access to an OpenStack private or public cloud, and you want to run some applications in containers, but without using Kubernetes because it's available or it's not an option for any reason. And of course, the other pattern that we see a lot in OpenStack development is the desire to run and manage OpenStack in containers. So before even reaching Kubernetes or any other high-level framework or orchestrator to manage a complicated application such as OpenStack, and there are several layers beneath and some complexity that is hidden, or there are also other options that you can use to manage OpenStack or another application like Ansible. So here in this session, we will check why you might not want to run things in containers and how are you going to do that. So starting and the other projects related to running containers on OpenStack. So first we will start from the application, which is like the core component of our architecture, and this will be packaged inside the container image. This all started as a change root in Linux, and then when we talk about container images, we usually talk about tarballs, which are essentially container images, Docker images, and in 2013 that they started being hosted in Docker Hub and being publicly accessible by anyone. So the first question I would like to pose to all of you is which kind of images do you consume? Like if it's an application, everything is built by you. You base you use some base images and you build on top. You just use the base images, and because you want to rely to the maintainers of the images, like you would do for applications coming from Linux repositories like in Ubuntu or CentOS. And then what do you do for multi-arch? Because even without containers, multi-arch is a challenging task to address, but also, with containers, there is a challenge in building applications for multiple architectures. But once you have streamlined the flow from development to production with containers and all the patterns and tools around it, it should be relatively easy. So usually when you talk about consuming an application like HTTPD or Python or Golang or Apache, you usually go to Docker Hub or another mirror in GCRIO way or your local mirror, and you pull from there. And for example, in OpenStack, Cola and Loki and other images are pushed to Docker Hub and key for users to consume. So I'm not sure, Ashley, now we watch for hands. How do you want to proceed? Can you hear me?
I can.
Okay. Does anyone want to jump in, or we just continue? Because this was mostly like a poll of I don't know, interactions. So at least I will start by from our use cases at CERN. So we run different kinds of applications. It could be web apps. We don't run them as cloud team, but our users, which are also our colleagues, run them. Or for us, it's web applications. Well, OpenStack is mainly REST APIs apart from the agents. So usually for unpatched projects that we have, we use the AppStep images that we mirror them. And then if we want to add patches and so on, we rebuild in GitLab CI and push to our registry. So this is also the next bullet point, which is how do you build how do you build images? What is the workflow of getting code from development to production? So in our case, we have a private GitLab instance that we host all our code, and we consume heavily the GitLab CI with shared runners that we use across the organization. And for images that we want to build as part of the OpenStack Magnum project, we consume Zool, which is hosted by the OpenStack Foundation. And then for upstream, we push to OpenStack Magnum, which is an organization in Docker Hub. And we have another mirroring key, but recently we don't maintain, since most users are pretty satisfied with Docker Hub, and either they rebuild locally, as we do at CERN, if we want to push some patches or use a tag that has a specific fix that is not upstream yet.
Can I have a question?
Yeah.
So what base images do you use, or you start from scratch?
At CERN, we have also a Linux team that builds some CentOS images that they use Image Factory for this. So for projects that are CERN specific, we use those base images, which is a fork of what the upstream CentOS project is doing. And for the rest of the images that we consume, it's usually, we try to judge what is the official repo that we want to get the image from. Then we mirror a set of tags for this to our GitLab registry. An example is core DNS that we want to run in our Kubernetes clusters. So Docker.io core DNS is like the official image, at least based on the repo. And we mirror selected tags, and then we get always the image from our registry, since we mirrored once every release that they do. Did this answer your question?
Yes. I have a follow-up question, but just stop me if I'm like deriving too much from the topic. So, like, do you have any, let's say, requirements for a like list of bomb switches in the base image of the container, or any requirements to know what is inside, or you just get something from the registry and use it?
So for images that we want to build ourselves, if we won't use our internal from scratch image, we will end up using Debian Slim, which is very minimal, if we want a rich set of packages that are in Debian, or Alpine, if it's relatively easy to build a small image, because usually there is a pattern that you, I'm not talking even for multi-stage builds, but what you can do is have a set of packages that you might want installed in the image, and then build something, for example, a pip install that is going to compile some shared libraries, and then uninstall, for example, GCC, you want it to be installed before, and then you want it uninstalled, or some build utils like make. So we either follow that pattern if it's not getting too complicated, and then either we use Debian or the in-house CentOS image, which tends to be a bit fat because you start from 60 megabytes uncompressed, and then you start to add things, because for YAM and DNF, you have already Python there. There is some work to have a slim CentOS with micro DNF, but it's not very widespread, and we don't really use it anywhere.
Do you squash your images, or you have the like install build tools, build and remove build tools in the same command?
No, where it's like one build. So what you described, it's mostly done by the Kubernetes project upstream, that they have 2 Docker files almost everywhere, that they build something and then they commit it, they save it to a tarball, and then they do it from scratch. But this is, it's losing some valuable information from the Docker file. So we tend to craft the layers as good as we can and to have a very small image, because really the benefit from a squashed image is like it's very low, and it's better to have, in my opinion at least, some reference if you do Docker history or Podman history, or with other tools to see the metadata of the image. Otherwise it's lost. You just have a build tag, some labels, if added later, and so on. Also, yeah, I didn't mention that for Golang projects, everything is from scratch there, of course, and with Cgo disabled to have it working like everywhere with a very small size. Do you have another question, or anyone else? I see some input from John and Fanji in the relative bullet for how do you build your images.
Hey,
yeah, in the build your own, yeah, tell me.
Oh, sorry. I was just going to say, I was going to share what we were doing with building our own color images, because you did mention the color project.
Yeah.
And I'm curious what other people do. What color generally does is it actually builds up its own custom images, and they're generally using OS packages effectively. So say you take the CentOS or Ubuntu base or whatever, and it builds up from that. And I guess, as you mentioned earlier, they can be a bit fat, but sometimes that's a benefit when you're debugging. Bash is definitely there, for example. Whether that's an anti-pattern or not is probably an interesting question. And yeah, that's
so yeah. So for applications like this, even for OpenStack, we start with images that are, to answer your question, not exactly validated that everything is working, but then everything gets deployed first, like the binaries, if are there or not. So the binaries are first in, the images first are tested to isolated testing environment. In our cases, at least for Magnum and the other OpenStack projects, we have like a testing region plus a dedicated testing deployment. So everything gets validated there, and then images with the same SHA will end up in production. And for going from fat images to like slim ones, usually you start with a fat image, you are getting comfortable, and then you go slimmer. And then there are other patterns you can do to debug images, like either access the host or run a very privileged container next to it in the same namespace, or attach with Kubernetes or Docker a container just next to it and do the debugging there. But this is like if you have a very fine-tuned environment and you don't want to disrupt anything, these patterns are useful there. But if you have capacity, a fat image can make your life easier.
I mean, maybe, if no one else has got questions, I'm curious how you put your containers on a diet. Like what approach you took to do that.
So putting a container on a diet is you must know the application very well and be sure what are the exact requirements. And if you're using a repository like Yum or apt, you must know very well how to use the package manager. A very common advice for apt is apt-get install minus no recommends to not install additional packages. In some cases, you might even get tech, which will explode the size. And for CentOS, you can do you can add the flag to never install documentation, because inside the container, man pages is not something that you need. Also, clearing any cache that you have in varlib apt or in varlib yum you don't need it while you run, because ideally you should never install something in the container. And based on what you're using, you can make even the file system of the container read-only. So the cache, you will not need it anyway. Another pattern is what I mentioned before, that you have like a very long run command or a script that is executed in the run statement in a Docker file that will first install some regex, and it will install the application, and then will remove whatever it doesn't need. So make or auto make, you definitely don't need when you're under your application. Well, if you need it, it's a very different story. Your application is very specific. So these are the main goals. And then for Golang, of course, and Rust, multi-stage builds is the holy grail, because you can get, it's impossible to get lower than that. It's absolute the slimmest.
And real quick, we actually just teed up a poll just to get a sense from the folks that are attending on who's running containers in production, or if you're just planning to and evaluating that implementation. So I think we're going to run a poll, Spiros, while the discussion goes on, just to kind of see what kind of content would be helpful for those folks. So I think we're going to push that live now. There we go. So please vote in the poll, and then we'll try to customize the conversation based on the responses. Thanks.
Well, it seems that the production containers have reached production, at least as we can see, but let's wait a bit more. So to continue, yeah, so one of the first things that is important for using OpenStack and containers is make sure that all the infrastructure behind it, like the registry and all the CI, is there. And then OpenStack provides like a great set of APIs, like the Nova API, storage APIs like Cinder, Manila, and Swift, and of course Neutron. That at some point this becomes invisible. So when we run, in our case at CERN, VMs, it's very fast to boot, and I think for bare metal, it's as fast as possible. It cannot get close to VMs, the speed of booting new servers, but at least it's very good. And all this scaling up sets of VMs, like either Kubernetes clusters or not, or pools of VMs, it's very fast. And with declarative deployment, even with Ansible or Puppet, you can scale like horizontally in many cases, and not thinking of the infrastructure, the OpenStack infrastructure underneath, because if it's streamlined enough, you don't even see it or think about it. So it seems that half of the people, at least, are using containers in production, which is great. And I think improvements in all the request, the infrastructure is very important. So even for people that run containers in production, there are new projects like the one that we started using recently, which is Go Harbor, which is a registry, an OCI registry, a compliant OCI registry for Helm charts and containers. And of course, there is GitLab and Nexus, but all of these are as good as, I didn't know even for the registry. This must be new even for me. But all of these projects are as good as their backend. So if you're running containers in production at a certain scale, distribution is very important. So all of these projects support S3. That could be Swift or something else. In our case, is the Rados Gateway, but it's hidden, or it's, let's say, included in the OpenStack catalog, that users can consume with OpenStack or the AWS credentials that OpenStack provides. And then very close to it, what's very important for, especially for production workloads that we struggle very hard to put in place at CERN, but it's very, very important coming from a world from signed packages with GPG keys, is image signing and allowing only images signed by a specific CI. And then image scans, because you might have a container running for a long time and at the same time CVs are discovered. But if you follow the pattern with read-only, you need constantly to monitor it and update it. If you're running in a, let's say, older system that runs Ubuntu or CentOS, you can do updates and get the latest packages from the respective registry, from the respective package repository. And also this is a challenge for while building, and even projects like the OpenStack Kubernetes SIG that it's in 2 sessions after today. We don't have their implemented signing of the packages. We just release the tarballs and the binaries, and we post them in the release page of GitHub, and in other cases. For the images, we just push the image there. So the goal is to reach a level as what we have for the release artifacts of OpenStack, which is in tarballs.openstack.org, that the tarballs are signed and you can verify what you download from there. Projects like Harbor that I mentioned, or I haven't checked the state on Zool, but GitLab as well, they offer, they can host images signed because the signature is part of the manifest, but all the tooling and managing the private keys is up to the operator. So this is a challenge, and it's not very well documented or solved, I would say. Has anyone solved this or has any suggestions? Because what I can offer on the table on the discussion is that we, if it's GitHub, we store the secret in GitHub. If it's Zool and Jerrit for OpenStack, we have the key in the Git repo encrypted with the public key of Zool and pushed to the Zool file, zool.yaml, or in their directory. And for GitLab, it's the same. You can have variables that are protected, and you can store them in GitLab, and then the CI will just use the secret. I think the optimal one for now, at least from my input, is Zool, that you can encrypt, that you have a master key that encrypts with the public key all the other secrets in, and you can host it in Git entry. Anything you want to add on this, or we can move on and go a bit faster to next topics, going away from images? Okay, so let's move on to how do you run containers. So in the realm where you have a Kubernetes cluster, this will be hidden from you, but there is something that will run your container for you. So it will download the image, unpack it, and create the change root and the namespace, and it will start the container, attach it to a daemon or systemd or something else. So the most popular, I think, at least even now, is Docker, and containerd is very close, even if it's already used by Docker. And if you're in the RHEL-like distribution, Podman is definitely there for at least lightweight containers. Kata containers are already in with lightweight virtualization, which is extremely useful if you want to have multi-tenancy in hosts that are consumed by different tenants, and especially if these tenants don't trust each other. So if you run Docker Swarm cluster, but is used only by one person with the Swarm API, it's fine to not have a very high degree of isolation. But if this Swarm cluster or a set of hosts that run Docker Engine is part of a CI, the code that runs there isn't trusted, the network might also host sensitive applications, and you want to be extra cautious there. And Kata containers there help a lot. gvisor is also another option, which shares similar semantics, or Rust VMM that has recently been published. But at least the most popular for now runtime is Docker, I think, in containerd, and Podman is used with the systemd pattern that you run Podman inside systemd unit. And this is at least what we do in the OpenStack Magnum project, and I think also the Typhoon Poseidon project is doing to run Kubernetes itself. So the kubelet runs in a Podman container, and you can push it even further, that even run containerd inside the container, because it will you will do all the appropriate bind mounts, and it will talk to run C on the host. Do you have any questions on that, on runtimes, or if you want to discuss something there? I see that the OpenStack collaborator is using Docker and Docker Compose. Okay, I see some action in the Etherpad, so we'll wait for some more input. Okay, there are some comments about the differences in Podman and Docker. It's not exactly the same. Yeah, of course. The goal is to mimic the API, but if you the Docker API, but if you have like special requirements, it might not be so easy. Unless ping in the Zoom chat, let's move to the next subject. So I think I see John that mentions what do you need from OpenStack to run your containers. Well, we definitely need compute to run the containers, but then these containers do not be just black busy boxes. You need networking and storage that they have 2 bullets after, which means storage is used either to share some state or to store some state. So storage could be block storage, or S3, or a shared file system, even SFS or NFS, or something similar. And then this is where OpenStack offers the great abstraction with its APIs that you can, well, and other clouds as well, of course, that you can interact with storage, and everything will be in code. You can test it in the CI, and so on. So this is even true for running OpenStack. Thankfully, in most OpenStack projects, the state is only MySQL. Well, only MySQL is not that easy to run, but it's a very well-known and established technology. But either you run it with Collapsible or just Puppet, or on Kubernetes with plain manifests or OpenStack Helm. The most important part is the networking that you need to achieve, but Kubernetes has already a very complicated stack for that. But since in this discussion we're excluding this, what is very important is, well, not very important, the most important benefit from running in containers is the reproducible environment, that if you have built an image based on Ubuntu or CentOS, you can run it anywhere you want and it will behave in the same pattern, at least for OpenStack, which is just quoting REST APIs for the control plane. And so this is extremely useful and easy to consume. Then if you're going to move to how all these microservices will interact with each other and what to do with networking, avoiding Kubernetes, the go-to solution is some proxy in front, and a lot of business logic will be in the either HA proxy or Nginx configuration, which will involve the virtual IP, which will involve also virtual IPs or DNS host name in the same IP, and path-based routing that even in DevStack, we use this pattern for all the projects in the catalog. Instead of ports and different IPs, we just use the path of the URI. Do you want to comment, or is anyone running, let's say, OpenStack in containers other than Kubernetes? Ansible is a very popular option, and TripleO recently.
I'm certainly a +1 for Ansible.
Okay.
So I can share. I guess it goes back to your point on reproducibility. So, I mean, we obviously work quite a lot in the HPC science space, and reproducibility is a big thing for our users. But not only that, this clearly obviously helps for OpenStack. It's really nice to know that the exact same binary that you executed in your test environment is the one that you're moving to production, and that simplicity is so powerful, I think. And Ansible certainly brings that to the whole stack. As I said, the Collar containers are, built in their way.
And apart from reproducibility is, of course, isolation done with features of the Linux kernel. And you can use control groups for not having. Keystone is one of the services that can be attacked first. And for example, number of connections there could be limited even per backend if we assume the front end is a proxy, or the size in memory or the CPU consumed by Keystone. You can always try to confine it in smaller space in your host and not affect other services, or even for bags. If you have a bag in, let's say, in heat, and it starts exploding number of connections or in memory, with these limits and features from the Linux kernel, you can achieve some isolation. Or if a service is compromised, you can still get away with the isolation that the container interface, it's not exactly interface, but pattern gives you.
I would say one of the big things I think I've seen moving to working with all containerized deployments, having previously worked in an awful lot of VM-based deployments, is actually the lack of isolation is also a benefit. So I should justify that slightly. What I mean by is we can put C group limits on all of the containers, but they can all share a certain amount of wiggle room, let's say. So if one of them does go crazy, you've got a bit of time knowing it's going crazy before it's going to hit the brick wall. So you can kind of go in there, take evasive action, fix it without actually hitting a hard limit, which you tend to hit in the VM world because you're effectively dedicating RAM for each of your components. So you have got a bit more flexibility with the container approach, which is very attractive when you're trying to, you know, well, just operate the system really.
Yep, definitely. Well, that's an excellent point, because you need, as you said, isolation, but also some flexibility, because you never know, you cannot always pre-allocate the resources.
And you said about isolation, I guess one of the key isolations is the version isolation. So if we just did, say, on one system packages for all of the components for OpenStack, this is a fairly common example, right? It can be a bit of a nightmare to say, oh, you know, Spiros has added this great new feature in Magnum, so I want to upgrade Magnum before everything else, which we've totally done. That's possible with containers in the sense that you can just, if the service dependencies are fine, you move it forward without even thinking twice about the package dependencies, because they're independent for each of your container images, which I'm sure hits most.
I think there is a very important all the path from development to production. It's easier to create it with containers than with RPMs or packages, because you have to set up repos, and there's quite some infrastructure around it. Because, okay, we mentioned all these benefits as for versions, but also with VMs we had achieved that before. But like the next iteration is with images, that the development flow can be streamlined more. That can be good and bad, because you have some flexibility and ease of use, but also it can be skewed, and you can get into paths that you don't control it very well, or it's a bit loose. The procedures for getting to from one version to another. I think I already discussed. Is there another point that anyone wants to raise about it, or we can, because I think we have around 10 minutes more or 15 to talk a bit about storage and networking. It's not much to say, you know, because if OpenStack works very well, you have Octavia as well there in Neutron. Maybe the networking problem is kind of solved. Okay, let's start from storage. I mentioned that the storage requirements might be different per application. You might need block storage, you might need shared storage, or just something to archive results like S3. So for Kubernetes, we have the CSI interface, the container storage interface, that there was at some point, I think, an attempt, and that CSI is there not only for Kubernetes. But even without it, we have the Docker plugins that Cinder as well has at least one plugin. I think it has two. One is part of Rexray and one is part of Fuxi. And the other option is to never have a state or something that you access via POSIX to your containers. So you do all the management of storage disentangled from the runtime. So if you have some hosts that you can have a container technology deployed inside, you can mount everything you need, and then you bind mount the directories, which are essentially mount points to your container to access it. This can be NFS, it can be Cinder volumes, CFFS with carved by Manila, or anything really. But I think in the cloud era, having an API there as well is a major benefit. Like if you have S3, you can do snapshots of your work, but the logic will be embedded in the application, or you can do immutable writes and let's say atomic writes to S3, because if you use name tags that have a timestamp inside or a signature, the operation to S3 will be atomic and HTTP post, and you will get the status code, and then you can try again or not. This is not exactly read-write many, it's read-write once, but the application doesn't need read-write many in this sense, because you have read-write once per file. It's read-write many for different files. So if each instance needs to write or read different files, S3 can be read-write many in a way. So yeah, I would be, say for myself, a great advocate of this pattern running with an S3 API. It would be Swift, Minio, or something else. But of course, the POSIX access is still relevant to many use cases. So if anyone else wants to add something there, what is the preferred pattern? Not sure if we are fast enough to run another poll, but if you want, you can just jump in and leave a comment or just open your mic.
So one of the challenges I think I've seen people struggle with is the fact there's all of these options and it's not entirely clear which is a great one to use for the particular use case, or not immediately clear. I don't know. So I've tried, I see there's some people adding notes actually. I tried to sort of write out the various ways you can attach storage with an OpenStack in the different use cases, just to try and capture what you're saying. So definitely there's the ephemeral local disk. And I know you mentioned MySQL. Like one of the things databases kind of like is low latency, right? And one of the easiest ways to do that is that you're using the local hypervisor disk. That's all good. The disadvantage is, in order to get a bigger one, you need to change your flavor size. So you kind of need to have predicted in advance what size flavor that VM, or in that fact bare metal, has by default. Which is where Cinder can be useful if you don't really know how much storage you need in advance, but it's the same kind of read-write once thing, but at least you've got that flexibility that as as your pod moves, you can reconnect the volume in the different places. Although I'm going on to a topic we weren't going to mention. But yeah, I guess, and the Manila is very useful for exactly maybe the person in red wants to comment. Don't know who that is.
I think it's Tom.
Maybe that's Tom, yeah.
Yeah, that was me.
We've definitely used the goodness of Manila, but maybe you want to summarize.
Well, I just tried to put down two of the reasons that I think Manila, kind of shines in a world with containers. One is that because it serves storage over a network and is not tightly coupled with Nova, it doesn't really care whether the consumer are bare metal or VMs or containers hosted on bare metal or VMs. And indeed, they can even span these groups of things. So there are some use cases where that's quite useful. We actually have some customers who are prototyping with that right now. And then the other is that it does what, at least in Kubernetes terms, is called read-write many, or RWX, but basically multiple concurrent writers with POSIX file system write arbitration. So you will note that, I'll note that read-write many is also possible with Sender today in raw block mode, which is a new thing. Where you access the block device as a block device and use file offsets to it and arbitrate writes via the application. So, for example, a database that works with raw block, but it's typically one application. It's not traditional Kubernetes, at least. I know we're talking about other container orchestrators here, but that's what I'm most familiar with, where a node local file system is applied right away. So for instance, Sender multi-attach, I've worked on Sender more than I worked on Manila in my life, is useful if you have a cluster file system. And I don't know about all the container orchestrators, but Kubernetes does not have one. It imposes a node local file system if you put a file system on it. So it's not safe. So Manila is actually quite useful here, and its lack of tight coupling with Nova, which might have been a disadvantage in the traditional OpenStack world, actually turns out to be a bit of an advantage in this new world order, as it were. Obviously, I can talk about this at some length. I'll refrain right now, but you folks know who I am. I'm interested in the subject.
Do you see NFS as an option?
Right now, Manila works through the cloud provider OpenStack. I know Anusha Ramyani will be here later talking about that with CSI provider. And the CSI provider currently works with Manila with NFS and with Manila with native CephFS. Manila is a multi-protocol abstraction, control plane abstraction for OpenStack. Upstream there's HDFS and CIFS and all kinds of stuff. But the two live ones currently here are NFS and native CephFS. Does that answer your question, Prakash? Or not?
Yeah, thanks. Yeah, that helps.
So for NFS, I work for Red Hat, and we're putting this is in production. So I'd love to see it in production with other distributions and so on and as well. But with OpenShift, it's currently running with NFS, and CephFS is queued up, but CephFS works fine upstream, and the CERN guys, I think, are starting to play with it with CSI. Maybe they're further along. They were already using the non-CSI provisioner from Manila with CephFS very, very successfully.
Yep, I can definitely agree to that. We did, and we're moving gradually to Manila CSI. So I think we have about 1 or 2 minutes. So thanks for the discussion, at least for storage, John and Tom. Just to wrap up, I would like to mention that all the infrastructure and all the projects around it for the CI image distribution and the different runtimes, different plugins to access and to access storage are crucial. And even if you use a big orchestrator like Kubernetes or anything else. And there are a lot of optimizations that can be done to achieve a great performance and a declarative way of deployment. I have also left some notes, 2 more points underneath, which is a subject, one of the subjects that we work at CERN recently, which is image distribution, because the registry can be a single point of failure of the application depending on the backend. And of course, caching and then architecture of the image distribution is very important. And what I wanted to touch slightly, because in all this discussion we assumed Windows Linux as the host, Windows containers are kind of a thing, and a large portion of the industry is based on that, but I don't think we have time today. So yeah, just to wrap up again, there's a lot of projects outside Kubernetes and Docker and the main ones, even for monitoring that we didn't touch today, like Prometheus, Grafana, and all the various plugins and exporters you can have for containers are extremely important. So thanks everyone for joining the discussion. I think Ashley will jump in, or someone else from the foundation. So I think that's everything from me. So thank you.
Thanks so much. That was great. Well, now we can roll straight into part 2 of that discussion, which will be a little bit more focused on Kubernetes. So I will hand it off to John.
Hi, everyone. Excellent. We have a new Etherpad. So the top few lines here are a couple of polls. So just as we sort of get started, if people want to try and pile in with their +1s or -1s with a comment, are also welcome. So I should quickly introduce myself while that's going on. Actually, we can kick off. Would someone on the foundation like to kick off the poll for us for the next poll?
Yep.
That'd be awesome. Oh, star, thank you. So I'm seeing people come in, thank you. So I'll introduce myself quickly. I'm John Garbett. I work with Stack HPC. We focus an awful lot on HPC and OpenStack and how to make that all work well together. My experience with OpenStack goes back almost getting up to the 10-year mark now. Been various things over the time, including Nova PTL and TC Member and Nova Core. But yeah, hoping to a good discussion about Kubernetes and OpenStack today. Okay. So we've got about 43% of the people voted so far. Excellent. Some more votes coming in. Okay, so while we're doing that poll, I just wanted to go down to this line 55 and talking about sort of how you actually look at running Kubernetes, generally speaking. So this, I guess, is actually a question more about how do you deal with Kubernetes multi-tenancy. I don't want to drop someone in it, but Spiros, are you still on the line? I don't know if you wanted to share how many clusters you have at CERN, just to put some information behind that tweet from Tim.
So I think it's around 500. So this number changes frequently, and I'm opening Grafana as we speak. So it's around 500 and over 2,500 servers, and in course even more. Let me log in. I will tell you the exact number. In the meantime, we can maybe continue.
Yeah, no worries. Sorry to drop you in it. So I guess in your case, you're so one of the advantages of Magnum is you can walk up and just press go, and there's quite a few ways of doing that that people are currently voting on, as in making it easy to quickly get a Kubernetes cluster. So I guess, are you seeing users generally all wanting their own cluster, or having more sort of the approach of multi-tenancy within the cluster?
So yeah, so the numbers were the exact ones that I mentioned. It's like 510 clusters, 2,500 nodes, around 10,000 cores. So yeah, with Magnum, just as you said, it's one click to to create a cluster like or one CLI command. And then there are two patterns users can follow. So the easiest one is one cluster, one tenant, and then many clusters because it's trivial to create many. So this is the pattern of clusters as cattle. So you have like a fleet of clusters that are small and flexible and they can come and go. Versus like a big super HA cluster that might be HA regarding failures in hardware, power, network, but one wrong configuration can hit the entire cluster, or if you compromise the massive cluster, you can compromise almost everything. So yeah, this is like the pattern that Magnum allows. The cluster API and Rancher as well allow this pattern. Kubespray is another way in KubeADM, but this is mostly the operator or the consumer of OpenStack is doing most of the work regarding setting up monitoring and so on. While in Rancher and Magnum, you have a lot of packages kind of pre-installed or components in Kubernetes, and with Magnum it is one layer higher than Rancher in the sense that all the accounting for Kubernetes is already for OpenStack that interacts with Kubernetes, like the tenant, the project, the delegation to application credentials or trust users is already there, while in Rancher you have to do some extra work for that.
That's an interesting point. So people are doing disposable clusters, but still wanting to use like app creds to talk to the Kubernetes API.
Yeah.
Or did I misunderstand?
This is a way to upgrade your infrastructure without touching the existing one. So you add extra capacity with new configuration and new versions without touching the old one, because if you go for minor releases, it's safe to do an upgrade. With Magnum, it's pretty easy to do it, and other projects, of course, as well, because the differences in versions is very small. But if you want to jump into other to either new hardware in your underlying infrastructure, or if you want to jump two versions in Kubernetes, you might want disposable clusters and add capacity gradually and remove the old one, as you would do with VMs.
Cool. We're getting quite a few good questions also in the Zoom chat. And I'm going to open in the floor to answer the questions. So there's some questions about edge computing scenarios and what strategies people are doing for their deployments there, what limitations they create. I'm also seeing lots of +1s from non-Magnum based tools. So I was wondering if someone from like Rancher or Kubespray or KubeADM, anyone that's +1 those, if you wanted to say, you know, what you're seeing, are you seeing these disposable clusters as cattle, or are you seeing sort of longer lived clusters and that kind of thing? Also, last few minutes or seconds for people to vote in the poll. So I think it's kind of interesting.
Yeah, it's mainly because Rancher and KubeAdmin, mainly because they are Rancher for simplicity and KubeAdmin is mainly you can customize. Those are the reasons why we choose that.
Okay, so a mix of both.
Yep, that's right.
Interesting. So for your clusters, are you seeing a mix? You seeing a mix between the long-lived clusters or clusters as cattle, or is it mostly clusters as cattle?
See, in the labs, we just they are all cattle. We just bring them and take them off. Not in the production, but in production they are long live usually.
So maybe that's a question to back to Spiros is if you're doing these clusters as cattle, how do you deal with like migrating workloads between your cattle clusters? Maybe you don't do that. I'm thinking like when you upgrade.
So there again, you need some kind of proxying and some business logic in your proxy. Recently, we are pushing also upstream to the cloud provider to be able to join different backends for in service type load balancer of Kubernetes. So if you have Octavia or something else to serve load balancing as a service, you can have different clusters there. And
so in that case, would you have like two different? You'd have like your A and B cluster both being behind the same Octavia load balancer.
Yep, that's possible. Or if you don't do that with Octavia, you can do it with another proxy, Nginx, HA proxy, or anything really.
Like, so your proxy would be outside of your Kubernetes clusters in this case, or?
Yep, in that case, it would be either in Octavia or
in a separate
managed load balancer. This is what we do for VMs at the moment, so it's almost the same. Either you manage the proxy with a tool, Puppet or Ansible, or even by hand, or you move that business logic to the cloud provider, the OCCM, the OpenStack Cloud Provider, Cloud Control Manager for Kubernetes.
So to do that, so to do this whole Octavia shared between two clusters, I guess, how do you do that without OpenStack Cloud Provider changes? Is that not possible right now? I guess you could do it between the pod IPs.
It's not merged this work yet, so we are discussing it upstream. We have done some tests already, and it's pretty straightforward. But if you don't have the cloud provider working or supporting this, you can either have in each cluster an ingress, or even a service type load balancer per cluster, and then in front put another HA proxy that you manage by hand. This adds some overhead. So the easiest one would be to have an ingress controller in your cluster served with node port or service type load balancer, and in front put HA proxy or your proxy, the proxy of your choice.
No, that sounds good. No, good context. Thank you. So maybe going back to, so Prakash, I think you mentioned about having long-lived clusters for apps in production.
Sure.
I'm just wondering if you wanted to go through what the main driving reasons for that were. Is it just that the apps in production don't get changed as much?
So the issue is obviously setting up once and running tests again and again is one. The other is once you establish, you only want to upgrade when the new Kubernetes, like 1.8 to 1.9 or 1.7 to 1.8. So upgrades are the only reasons we want to maintain. Once you have the other factor, obviously load balancing, as you mentioned. Example, if you have Nginx, then you use whatever Nginx itself supports. But node ports are risky. We don't prefer. So whether we use a ingress controller or a load balancer, obviously I have not tried some of these like Octavia. I know for long, but not tried it. Preferred somehow to go with HA proxy, which has been traditional. And so what I see is it's always the question of scaling. And that's one of the reasons you stay put on one for a longer time. The other is upgrade. Or I would say, like example, Go changes, Go 1.3 to 1.4, then you are again stuck. You don't want a lot of changes together, but you want step, what do you call, selective upgrades. And so for a long term, we prefer to go with selective upgrades and test it before we really change the production. So this is more to do with the business criticality of the cluster, and obviously we do have also to worry about sometimes on the what do you call the VIO part of it. So when we have VMware and Red Hat and combination thereof is more challenging.
And
But
maybe just to probe into that slightly, is that within a single Kubernetes cluster?
uh, usually not, but we do get asked for it, and so we do experiment. Yes, we can do it. It's not like you cannot do it. You can do it. But that is the provider network part which we'll have to worry about then.
No, that makes total sense. So in my head, I'm just collecting data for between these two approaches, right? The long-lived cluster and the disposable cluster. I think that's really quite interesting. So just to double check, the Kubernetes upgrade that you were talking about, Prakash, within the long-lived cluster, I'm assuming that's kind of an in-place upgrade of the Kubernetes.
In-place operator. That's
well,
right.
No, sorry, in-place upgrade, yeah. Kind of.
Yeah, in-place upgrade, yeah. In-place upgrade, yeah, that's right.
And to and Spiros, just to make sure I'm not misrepresenting what you were suggesting, I guess in your disposable cluster world, you just have the old and the new next to each other, and you route traffic between them, sort of outside of Kubernetes, effectively.
Yep. So you control the percentage of flow in the proxy level, and then gradually you remove backends from that run in the old clusters. So all this can be done, all this logic could be called the service mesh logic that could be served from a single cluster or many, both with advantages and disadvantages. At least coming from the world with OpenStack Magnum that we struggled for some time to implement in-place upgrades, and seeing that the success rate is much higher when you dispose either old nodes or old clusters, because even with Magnum you can, or just not only Magnum, like this is a pattern you can follow with the cluster API, for example. You can have a pool of nodes, a node group in Magnum terminology, with version X, and then you can add another one with version X plus one, and do the non-in-place upgrade like this, which is in place in the same cluster but not in place per VM.
So for this approach, you kind of, this individual user kind of needs double capacity for some time, I guess, because they've got the old and the new next to each other.
It's not it doesn't have to be double, right? It could be per VM, like it's not necessarily double. You will have double the control plane for sure for some time, but if you have many clusters, even for that it's not double. If you have always five clusters for your production workload, you can replace one by one.
It's double per individual cluster and application, but not double in aggregate, I guess, right?
You need some extra capacity anyway.
Additional capacity required for that. So if you were to use Kubernetes, if you were to use 3 Kubernetes clusters for this setup, so you have Kubernetes doing the proxying at the top to the Kubernetes below. I don't know if that's even really a thing.
It's possible, definitely.
Yeah, I mean, basically, I'm saying run your proxy inside Kubernetes. Then you would have to do an in-place upgrade of that top Kubernetes, I guess, right? Or would you fail a bit over?
You can do that. You can do that, or just replace it by another one. It depends also in the infrastructure below, right? With Octavia, it's easy to add another one, and your Octavia might support or not virtual IPs. You can even move virtual IPs or having DNS load balancing. So it also depends on the infrastructure below and the complexity you want to add. But
So
another point I would like to add for in favor of disposable clusters is that if you have this kind of pattern, you can also ensure that at any time your disaster scenario, a recovery from the disaster scenario is in place, because if something fails, you can easily uh, put everything back together very fast, because you have streamlined this process. Because if you have a big cluster, uh, maybe or maybe not. You depend a lot on that cluster and assuming this is always there, which can be true. It doesn't mean that it will fail or anything.
That sounds good. Prakash, you had a question.
yeah, once you said Kubernetes hierarchical implementation of cluster, that's interesting to me. So I was just wondering, did anybody try that, and what exactly you do to the HCD then? Does it have three HCDs? And okay, we'll get there. Yeah.
I have exactly the same question. Did I just invent that in my head, or is someone doing it today?
Interesting.
My developer at heart is strong. It's just more turtles, right?
Well, we have done that definitely, not for production, because we invested more in the networking infrastructure and having Tungsten Fabric behind Octavia, the Octavia API. But we also even have even more skewed patterns, like this work was discussed between me and Thomas from our CERN team, to have virtual kubelets that are clusters essentially behind. So the level of multi-Kubernetes hierarchy can go in very, very deep. It's up to you. But
Yes.
for the question of having the proxies running in the top level, it's again up to the network. So how do you get the traffic into the backend clusters? You use the host port or the node port or service type load balancer, so that the front end clusters can talk to the backends. There are teams that are doing this, like one of the experiments at CERN is doing this. So they run the front ends in one cluster and the backends in another one. And there they're using host port, not node port, like just host port for the English controller for every cluster to go to the deeper levels.
Yes, but for production, this will be a risky one, I think. It is. Would it not be better to use Envoy or a service mesh in this case?
So I think we should probably move on to talk about networking specifically.
Okay.
Because I think that's a really good thing to dig into. We've got a question, for example, on this on the Zoom chat. Actually, this question's about Edge and Kube Edge and things. Do feel free to raise your hand if you want to say something, or oh, actually we haven't turned that on.
Oh.
Feel free to put something in the chat and say hello if you want to.
That was me. This is Beth. Yeah.
Hey, Beth.
Yeah. Hi. Yeah. Kube Edge has come up a couple times. I guess it's a new Kubernetes product. I know almost nothing about it, but it seems like something worth pursuing. And I don't know how much I mean, I'm obviously interested in Edge, so, that's why I'm interested in it, but I don't know if others know anything about it. So just throwing it out.
Let's put that on the back boiler. If someone wants to speak up about that, feel free to pop something in the chat. So I was going to talk about networking options, and this speaks a little bit to the question around HPC and containers, but I'm going to stay straightforward on the networking to start with, I think. So I'm just wondering if people wanted to share. So actually, we should just talk about the poll quickly. So the poll showed that about 30% of people are in production with Kubernetes and OpenStack. So I'm talking definitely to that 30%. Please do speak up and tell us what you're up to, and do share. That'd be great to find out more about that. And the reason I say that is because 40% of the people are here to find out and find out about what you did, basically. So that'd be awesome. So I guess one thing I wonder if people had a take on was like double encapsulation. And what I mean by that is if you're running your VMs inside a private network, be it created by Magnum or whatever, then, and I think, yeah, someone's going to mention Courier, which would be good to talk about. In that particular case, you often then have like another network encapsulation happening inside that VXLAN. So you get this double encapsulation. And indeed, some people thinking that they get VLANs to their host actually have double encapsulation in the switch, if your switches are doing VXLAN for their L2. Not that that affects the NIC offloading. But we've certainly seen VXLAN performance within the virtual stack be very poor if you don't have good offloading within your stack. But I don't know if people have got particular stories of that, or whether everyone's just muddling through, hoping for the best. I'm curious.
So for performance for the VXLAN or another type of encapsulation, we noticed that the underlying architecture must be well thought in advance when you deploy your application. So if you have something low latency, it certainly must not cross subnets because the performance impact is great. And if you do VXLAN encapsulation across them, you will notice quite a performance impact. And I would also like to add that if you're using the pattern that we were discussing before and you have a service meshy kind of architecture, you can assume, or you must trust a bit the networking infrastructure underneath it, and in general the infrastructure making this kind of decisions. So it depends on which API you want to put your trust and confidence on. So either in your in-cluster network or the infrastructure network, because you will consume a lot the host network. And always, I think Tim Hawking from one of the creators of Kubernetes was mentioning that initially Kubernetes was coming out from Borg was mostly running containers, and the team implementing the solutions. So for putting traffic and passing the traffic to those containers were different teams. So the architecture there must be of the underlying infrastructure, and your application must fit a bit. Like you must also take into account the underlying architecture.
So there was someone talking about disabling port security, which always piques my interest. I don't know if they wanted to talk through that.
Yes, hi. I'm Chris. That was primarily for replicating a bare metal setup to OpenStack, and I wanted to be as close to bare metal as possible. So I disabled port security at all, and I was able to talk. So port-to-port communication does work directly. I have a virtual switch within that, like a Cumulus switch, doing BGP in there. And when there is, because I wanted to replicate the hardware setup as close as possible, and that did work. So the only thing you have to take in consideration is how to propagate the routes, but well, that could be done by Calico or by KubeRouter, depending on what you need.
Could
you
you
can
not
also you could also go the way that you add the allowed address pairs. When that matches, it should be possible as well without disabling everything. But it's it's a little bit more clumsy than just disable it when you're close to bare metal.
The IPs in there, would you have to repopulate that with all of your pod IPs, or well, the pod IP range?
As far as I know, you can update that with CIDRs, but then you have to use the host CIDR or well, you can even use the overall what you configured as cluster CIDR. That should be possible, but I didn't test that. With port security disabled, it works.
And so in that particular case, were you involved in running the OpenStack that you were running on top of?
I'm running the OpenStack as well, yes. So I'm running the OpenStack underneath, and I'm running the Kubernetes on top of. And the Kubernetes is there for running OpenStack, but on bare metal for sure. But it was just to get the deployment clear.
Nice.
And get some kind of environment where we can do automated testing without having to have bare metal nodes for having a lab where I can test my code on.
Yeah, so I guess that's a good point, is that if your production is bare metal, then you kind of need the dev environment to be the same networking setup, otherwise dragons.
Yeah, definitely. Yeah, I even created, as I mentioned, Cumulus switches. We run Cumulus in production as a switch, so a pair. And I installed Cumulus appliances into OpenStack and used them as the switch where I connected 2 legs of the VMs to, and then I have a management link where I can SSH into, and everything else is done via BGP over the Cumulus switches. Like like a fabric setup.
Oh, and so in your, and I probably got too many levels wrong, in your bare metal cluster that's running Kubernetes, I guess is running OpenStack. In that particular case, you've got bare metal machines with the Cumulus switches in production. So this is the dev cluster. Got you.
This is
which presumably is running on the other one. Yeah. Okay. Yeah.
The Kubernetes with the Cumulus is running on bare metal.
Yeah.
But I lifted everything into OpenStack to have a dev environment there. So with the 2 switches and the fabric network and BGP set up everywhere.
So in that case, your the network on which that you've got the port security off or allowed IP address pairs, depending on whether you do that, that network, physically speaking, on the wire, is that like VLAN encapsulation, or is that just a generic...
Well, underneath, yes. So we use Open vSwitch underneath in the cloud, yes, with VLAN encapsulation. But the path between the virtual switch and the VM is just plain L2. And also all traffic between the pods is just L2 traffic direct that's directly routable over the switches for sure, because of what we have in bare metal.
Okay, cool. Very interesting.
Yes,
and
sure. Very interesting. I also was thinking through, but so don't you use IP virtual services to segregate the overlay underlay? Or just use the bump traffic? I don't know where exactly the distinction between underlay and overlay comes in this case. What you have been describing, I'm just a bit lost in this thinking through. So if you do everything in the bare metal and with what you call Cumulus and everything in the underlay, that means you have everything at the physical level being done with whatever you have, whether it's a VLAN or with real-time Linux and all that, with all the drivers and all, with kernel drivers and all. But on the overlay side, you say you're using BGP to go across. What happens to your overlay side?
Again, the last words. What happens to?
Whatever overlay you're doing, you don't do any overlay, you mean? You just focus on everything on the underlay or bare metal only?
We are focusing there on the bare metal Kubernetes where we run also OpenStack on top of. But this dev setup, what I was referring to, is really just matching physical hardware as close as possible. And it's a traditional fabric setup, which makes running Kubernetes a little bit more difficult. So we have two interfaces in each node, so each connected to one of the switches. And then we have a service IP or a canonical IP, which Kubernetes kubelet uses as the node IP. But we have both ways where the traffic can come through. So that's configured via equal cost multipath. So we can saturate both links, and if one link goes down, everything works over the other one without any huge package losses.
Okay, so you're ensuring the reliability. Okay, got it. Thanks.
So I think a good segue from this conversation is to line 130 in the Etherpad. And partly going to hit on the next topic as well. So we've got about 10 minutes or so left. Is bare metal versus VMs? I think, Christoph, you made a great point. Like, you know, I guess you're using bare metal for production and VMs for testing, effectively.
In this case, yes, but that's only one part. We also use Kubernetes on top of OpenStack that is deployed by Kubernetes, which is kind of cluster API machine controller. But those are two separate things. But the bare metal stuff we use especially to be in edge locations, in fact, where we come with a very low footprint of machines. And so we even install Kubernetes component onto the Cumulus switches so that we don't have to, so that the customer has as much capacity, compute capacity available to him as possible. And for some customers, we run OpenStack on top of that. So but we need some kind of management plane, I would argue, to deploy stuff on those edge locations, and we decided for Kubernetes to do that.
So so the cluster API perspective, your kind of kernel of the cluster is basically the Cumulus switch, I guess. Is that where you do the initial?
No, the cluster API part is separate. That's kind of alongside.
Oh, that's for the
Magnum.
other side. Okay.
That's for the other side. You can technically do all the stuff with cluster API on bare metal as well. We decided against that because the setups are very static. So we come with a low footprint, like let's say 4 nodes, or that's sometimes when there comes an OpenStack setup, it's maybe 20 nodes, but it's fairly easy. We don't need the cluster API capabilities. It's just a PXE boot and a kube control join. That's it, basically.
Oh, that's a good point. The restrictive capacity in the edge kind of means you want all the nodes on, right?
Yeah, well, we have some restrictions there, especially around cooling and power. So while cooling is the most important part. I mean, we ship racks there where we have much more capacity. So small they are. I don't know how huge they are. Maybe.
Oh, sort of half rack thing.
Well, it's a half rack. It's a special purpose rack. But with the cooling on top of that, but we can just put half. We can make it half full of compute nodes because of cooling capacity. So those are the limitations on the edge. So you don't get enough power, and you don't get reliable internet, and you don't get enough cooling.
That's interesting.
I suppose sorry, Prakash, go ahead.
Yeah, that's interesting because how much do you need to maintain some temperature levels which are different from 20 to, let's say, 25 degrees centigrade? Or is it?
I'm not so much into how much capacity we do have.
Mm-hmm.
I should have prepared because we have a sheet. We have a sheet about that. But the thing there is, those edge locations are not in a data center. They are meant to be at an industrial building on site, like to So they might run some software on top of it to measure their production line, make photos of the parts that come out, push them into the application, and find out if they are correct or not. So they are in the building. They are not in a data center. They are just in the construction site building. And,
I see.
So and therefore we ship our own cooling on top of that, but well, it's limited.
Yeah, so it is air conditioned basically. You need to condition the air. Okay, so power goes in that, and on top of it you have servers that consume power, and so power limitation will.
Power limitations for
yeah,
cooling and compute.
Correct. Get it. Thank you. Thank you for that.
So I'd love to dig into. I guess the other point I made. Sorry, I was going to is you were saying about the dodgy internet, which is a strong feature of the Edge. And there's the Edge working group for OpenStack, by the way, has some really nice architecture diagrams about this, which are really useful to describe that. This is great to talk about. I guess that's why you've got a Kubernetes controller on your Cumulus switch rather than outside of the Edge, right? So your Cumulus.
Yeah, indeed. Everything. We want to have everything on site without any connection to the internet. So the future plans also include offline upgrades, like someone's coming there with a USB stick, and and all of the images that are needed for the Kubernetes are in that, and so we can update it in place.
And my assumption is that's more that's like a bandwidth constraint. If you're having to pay for that bandwidth, you send someone with a USB, right?
Yeah. Or not just that. It could be, or most likely. Well, it is internet connection, because in Germany it's kind of poor where the industry lives, which is sometimes far away from big cities. But more important, there might be compliance concerns, so that people don't want to be connected at all.
Okay. Yeah. Okay. That's a good point. We probably should have dug into that with the container images, because that's a big one where you need to rebuild on site. So I think we're almost out of time. I guess I was wanting to touch on the HPC thing, because we were basically saying about bare metal versus VMs. And one of the things we've been doing is passing through devices, so PCI pass through into the VM to try and get more performance out of the VM. And the idea to do that is really, if you take the bare metal approach, so you just give an untrusted user the physical machine. In the bare metal sessions, the previous OpenDevs, we've talked about the security problems therein. So these VMs give you that little bit more feeling of the security. So and the two things I'm thinking about here are SROV. So if you wanted RDMA networks and high speed throughput, you can actually have the virtual function passed into your VM, which is then given to the host networking. And for the GPU in a similar kind of way. I'm wondering if people have been exploring any of these things to try and get that, to remove the delta between bare metal and VMs when hosting Kubernetes. I don't know if anyone's got anything on that. I'm going to probably drop a coworker in it because I think he's in the call. Bharat, are you on the call? He's probably gone for a coffee. What I was wondering is that we actually hit some issues where SROV only works once in some cases. So if you pass in the virtual function, then you can't get Kubernetes to manage your virtual function. So you have to pass a physical function into the VM for Kubernetes to then manage virtual functions on top. And I was wondering if anyone's actually worried about this, or if it's only me worrying about it. I mean, Kurt, maybe you asked, was it Kurt on here that asked a question about, maybe Martin was going to speak up there, about HPC and Kubernetes. I was wondering if people wanted to talk about any of the performance concerns there. Kurt, you said yes. That's good. Feel free to share your perspective here. Oh, interested in GPUs under Kubernetes and Magnum. is I don't know if the CERN folks wanted to talk about GPUs. Certainly, I've seen GPU pass-through into the VM work very well to then use the host GPU within the VM. But we do have this nested problem as well, and that you can't do well.
So for GPUs or vGPUs for Kubernetes, at the moment, as you mentioned, we have the pass-through solution in place, and then we deploy the NVIDIA, because at the moment all our GPUs are NVIDIA. We deploy the device plugin as a daemon set to expose it to containers and the Kubernetes API. We're doing some work for vGPUs, but we don't have any experience with Kubernetes so far yet. So, and also some info about this this plugin. Since we consume Fedora CoreOS now, and before we were consuming Fedora Atomic, the drivers need to be built for a certain version of the kernel. So we had two modes. One is that we tag images that have the kernel modules inside for a specific kernel plus NVIDIA driver version. And the other mode is that if the daemon set gets deployed in a node that the kernel version and the driver that don't match, it will try to build in an init container the kernel module, and then that's the normal container.
And that's probably a good place to stop, actually. Spiros makes a very good point there that kernel, inserting kernel drivers into your well, cut down OSs that are running your Magnum clusters is an interesting dark art. I suppose the best thing to say is that we should probably talk about this within the scientific SIG. There's a working group within OpenStack that is very specific to HPC and scientific workloads. We should.
But all these concerns for kernel plus version, like, it's not.
No, that's not specific for sure.
Fedora or what we have chosen, but yeah, with Ubuntu or CentOS, you will face similar problems. Maybe slower speed in the kernel releases, but still, the problem cannot be solved by building all combinations.
Yeah, that's a good point. And I suppose the convergence in AI workloads all needing GPUs and other things is kind of meaning that this is becoming everyone's problem rather than a niche problem. Oh, well, Alison, I guess we're timed for, I don't want to take everyone's break away. I'm pretty sure I did last time I moderated.
It was a great discussion though, so thank you for moderating. But yeah, so we're gonna take a 5-minute break. We'll return at 10 minutes after the hour to talk about OpenStack Cloud Provider. So come back in 5 minutes and we'll play some music, and if you wanna hang out, but we'll return shortly. All right, welcome back, everyone. We're now going to go to the last discussion for today, and it's going to be SIG Cloud Provider and Provider OpenStack, moderated by Anusha and Christoph. So with that, I'll hand it over to them.
So hello. Yeah, just a few words. So just a few words to me. As I mentioned before, I'm working a little bit on Edge stuff, but also on the cloud provider OpenStack. And today we want to discuss what happens there, yeah, why we need it, and if you are using that would be very interested. And when you are not using it, why you are not using it, and where we can help as the maintainers of this project to go further and help you in using it. Yes. Anusha, is there anything to add?
Yeah. So, audible, right? Hello?
Yeah, we can hear you.
Yeah. Okay, thanks, Chris. So, I'd like to start a little bit introduction about myself. So, I'm Anusha, working for NEC as a developer and also the co-lead for the provider OpenStack project. So, yeah, I think please log the names of the parties who want to participate, and asterisk before your name so that we can invite you to the discussion. Okay, for those who are new to the project, so a little bit of background about the project. So SIG Cloud Provider is a special interest group within Kubernetes, which focuses on cloud provider integration. So provider OpenStack is a sub-project of that SIG. And for any Kubernetes deployments on top of OpenStack Cloud, provider OpenStack acts as an interface between Kubernetes and OpenStack. So this enables Kubernetes to talk to underlying APIs and leverage various of its services, etc. So that's a brief introduction about the project. As part of the project, we host a number of plugins as well. So OpenStack Cloud Controller Manager is one of the main components, which is an implementation of external cloud provider. So I think poll is up. We can start the discussion on that. Chris, over to you.
Okay, then let's get ahead. So I think the next poll kind of thing on how you deploy Kubernetes on OpenStack, we can a little bit skip, because we had that in the previous section, and I think there was a huge amount of Magnum users. So I assume that that all the other options are. Maybe I want to know what the other people that are not using Magnum are doing to get the cloud provider running, because Magnum does it for you. Kind of. Is there anyone who uses something like, let's say, just kubeadm and has deployed cloud provider OpenStack, or the cloud controller manager, to be more precise? Seems not to. So then I just step a little bit.
So I did something on the OpenStack provider, but that is using Kubernetes cluster API. OpenStack provider for, so that is still, the work is going on. It's not still completed, but it's in the development mode in the cluster API under OpenStack provider.
That's great to hear, because we have some options here maybe that are not yet with the new style of let's say, new style of Cloud Controller Manager. So maybe the question is, should I tell a little bit about how or why we need the cloud provider OpenStack Cloud Controller Manager, or why it's there and why we are not or why we don't want to use the in-tree Kubernetes one anymore? Maybe that would be good.
Sure,
because I don't know how familiar the people are here. So in the old days of Kubernetes, we have cloud providers in-tree, which is, they are in the Kubernetes binary, specifically in the Kubernetes binary of the Kube Controller Manager. And that takes care to talk to your cloud provider. Let's say if you have a service type load balancer, then it went to either Octavia or the Neutron LBus API and takes care that the load balancer is in place. So that's great. But we have a number of cloud providers out there, and you have to compile everything into this single binary. So now we have, in the Kube Controller Manager, we have OpenStack, we have GCP, we have Azure, we have all the large ones for sure, and some of the smaller ones. And the idea between the out-of-tree component is that we have just a Cloud Controller Manager, which does not have any code related to cloud providers. Like, there is no OpenStack code anymore in the future of Kube Controller Manager. And so we moved all the logic out of the tree and have our own repo, like the cloud provider OpenStack. And there we created the Cloud Controller Manager for OpenStack, which started as almost the same code as the in-tree one. And all the others do that as well, so that we don't have any code in Kubernetes core related to cloud providers in the future.
So am I understanding that you are doing a standalone Magnum or something? I'm still...
No, it's not standalone Magnum. It's like the Cloud Controller Manager is there to talk to your OpenStack API. It's there, well, specifically for the node management, like setting failure domains on the nodes from the VMs from OpenStack. And it also takes care on the service type load balancer. So creating the load balancer and adding all the nodes to the load balancer. And there's also a route component which can utilize the Neutron router to set up a route. So that's also a thing how you can use Kubernetes on OpenStack without encapsulation. Is like when you propagate the routes on the router, but that comes with the disadvantage that you have to that each traffic has to go through the virtual router. But anyways, so
I would just like to mention that the OpenStack Cloud Controller Manager serves a very different purpose of the Magnum project, and the Cloud Controller Manager is used by default, and it is assumed that it's there, and it's extremely useful to any, I think, Kubernetes deployments.
And
the in-tree removal, just as a comment, just the in-tree removal was one of the greatest things that happened to us that are taking care of managing Kubernetes clusters.
So yeah, it is not. So it's an addition to Magnum, so to speak. Magnum is the deployment of a Kubernetes cluster, while the Cloud Controller Manager is something that sits in the cluster, watching for events for load balancer, for instance, and talking to OpenStack, bringing that in place. And this works on all Kubernetes clusters running on top of OpenStack. Technically, it also is possible to run it outside of the cluster, because it just needs to talk to the OpenStack API, even though it doesn't make much sense. Yeah, and with the removal, we have some advantages out of that. So when we were in-tree, we were pretty tied to the release cycle that Kubernetes does. And it was kind of difficult to get things into core just for your provider. And now it's fairly easy. And it's also fairly easy to implement the API if you like to roll your own stuff, because you don't have to compile it into Kubernetes anymore. And you don't have to maintain your own kube controller manager. You just have to build your own small controller, which is responsible for the parts you're interested in. Like,
so is it a OpenStack control plane over a Kubernetes cluster using Magnum?
it is installed on Kubernetes clusters that use Magnum, yes, in newer versions.
So how do you handle the namespace for the different clusters in the whole space?
It is running in the installed Kubernetes cluster. So it does not run outside of the cluster. It does not run in the OpenStack control plane, but rather it runs in your small Kubernetes cluster that you created via Magnum. So it runs, so to speak, it runs alongside the kube controller manager, which also runs in your cluster. Is that clear?
Yeah, kind of, but still I'm struggling to figure out what. So what's the purpose of this? Does it make something better? What is the uniqueness of this advantage?
The uniqueness, well, the uniqueness of bringing it or removing it from core Kubernetes is that we have smaller binaries and that we have better, or the code is more maintainable of kube controller manager. And the Kubernetes project decided that they want to have no dependency on any cloud provider in the core anymore. So we needed to extract that. So that was a push from the Kubernetes community that we must get rid of all the cloud provider specific code in Kubernetes core, which totally makes sense because I don't want to carry GCP code when I don't need to.
Yeah,
so,
that's the part of cluster API, I thought. Is this...
No, the cluster API as it is just a provisioning mechanism like OpenStack Magnum. So you get your Kubernetes cluster up and running, that's fine. But when you use that cluster and then you create a service type load balancer,
correct,
then a load balancer must create it somewhere. And this is what cloud provider OpenStack does.
I see. So the main you are saying uniqueness is to create the load balancer before even you do any cloud provider.
No, you are the cloud. So assume that you have a running cluster.
Correct.
Okay, and now you want to expose something to the internet. You must have you must have some way to create a load balancer. And in the old days, kube controller manager was responsible for doing that if it was configured with OpenStack. So, and now instead of configuring kube controller manager, we deploy the cloud controller manager for OpenStack with the correct credentials, and then it goes to Octavia and creates the load balancer and assigns all the nodes that are running in the cluster to the listener.
So got it. So if I interpret it, so if I put it this way, that you are replacing the Kubernetes API controller with the OpenStack API controller, that will do the load balancing to start with, to support any cloud provider.
It's not the deployment phase. It's more the phase when you have a running cluster.
Okay.
So that you get traffic to your application that you deployed to Kubernetes. If you do an Nginx deployment, as an example, and then create a service load balancer, then you get traffic, you get a floating IP, and you get traffic through that load balancer to your Kubernetes service. Correct. So that's one of the purposes of the cloud provider OpenStack.
Sure.
And it also takes care on talking to OpenStack API and finds the failure domains for your nodes and sets the labels appropriately. like the data, the availability zone in OpenStack reflects as a failure domain availability as a label on the node, so that you can technically deploy a cluster over multiple OpenStack availability zones. And then you can have an anti-affinity for some application you are deploying, so that all pods run in different availability zones. So that's also cloud provider OpenStack who enables that, who sets the correct labels. It doesn't do anything with the scheduling, but it sets the labels so that the scheduler can use them.
So Prakash, is it clear, or like if you want in the simple terms, like if you have an OpenStack cloud and Kubernetes you installed on top of it, so you want to leverage a volume management, like you want to use Cinder for volume management inside Kubernetes. So this project does it for you.
So
yeah, I'm absorbing it, and I'll read myself before I can question. But this is see, Kubernetes on OpenStack and OpenStack on Kubernetes. These are actually inverted totally. So it does create some confusion.
It certainly does.
Yeah, it's basically Kubernetes on top of OpenStack.
Yeah, got it. Yeah.
Okay, and then we have a couple of other components. So that was the main component. But we have another thing. While I would, could you scroll down a little bit, please, to line, let's say 80? Thank you. So I would skip the ingress controller part for now, because the storage interface comes close to what we had before. So as I mentioned, Kubernetes wanted to get rid of all the stuff that is related to any cloud provider. So not just the things I mentioned before, but also storage. So before, storage was created also by the kube controller manager. It went to the Cinder API, created created a volume, attached it to the correct host. The kubelet had some code in place to mount it to the correct location, getting information about that, and so on. And all of that was also revised in the past, and people came up with the controller storage interface, or CSI. And we have a plugin for Cinder and as well for Manila. Yeah, and this is again the same, like you create a storage class as before. You have one of the plugins deployed, and if you create a stateful set, or if you create a PVC with the correct provider configured or the storage class configured, then you are able to create volumes and mount them to the correct location. And here again, the core idea behind that was to get rid of all the cloud provider specific code. In this case, the container storage interface is even broader than just specific to Kubernetes. In theory, each orchestrator, like let's say Nomad or Mesos, implements that. So you just need to have one code base for talking to OpenStack, and the specific orchestrator talks to your driver. So this is the advantage here. Okay, I wanted to.
I would like to ask a question regarding.
Yeah, welcome.
This. I think the container storage interface is great and works really well, but taking this pattern from this interface, would it be interesting for you that we maintain the cloud provider to have plugins for the provider? For example, if I want to add some hooks in the logic of the creation of the load balancer, to add hooks that could be either in the same way as the plugins that the kubelet has, talking via socket, or something similar? Do you think it makes sense, or just adding it in tree with a good design with the community would be better? But this would also be a bit slower, and not all use cases are meant to be used by everyone.
Yeah, that's so I don't have a strong opinion on that, to be honest. I think that we should strive for having the best possible or the most default way implemented in the cloud provider. I'm not sure about, well, the idea with especially the load balancer, because this is a thing that I think is also up to this discussion, because I don't know if you know about the Service API version 2.
Yeah,
I will
I've read about
link.
it a bit.
Yeah, maybe I find it. Otherwise, no, I don't find it. But I will add a link to that later, because this is the idea. Tim Hawkins is also involved into that. That we have Kubernetes. Let's must certainly go there to this one. So this API is meant to be close to what container storage interface is. Like you have a little bit more control over what you can create. You will have something like a gateway class. So that is something similar to storage class. Then you have something like a gateway that is, again, similar to a persistent volume, so to speak, like because the load balancer is brought in place. And then you have the routes that belong to the service. So then you can implement each and everything like you want to, and you just have to implement the parts you need. I think that's going to be the correct step forward.
This sounds great. Just a small follow-up. Do you think, or if you know, this will be like a loose API as the service type load balancer that we have now with annotations, or it will be stricter? Because I think this is one of the problems that led to the situation we have now.
Definitely, it does. It will be stricter. So because you can, the thing is, it's just referenced back and forth. So you can from your gateway, you can reference whatever implement the route you like to. So you can be very specific in that, because everything is a CRD. So the gateway class is a CRD, while the gateway is a CRD, and what brings the route in place is also a CRD. So you can be very specific at each point, and you can bring up new types that just is available in your cluster, and you just reference it from the gateway, for instance.
The final question, because of what you just mentioned, this will be the same for all cloud providers? It's not defined yet, or it will be different like we have now for all cloud providers like we have with annotations?
This is going to be for all cloud providers. So it's everyone can implement it like he or she wants. And I think there will be implementations for all the major cloud providers. So it's up to the idea behind this is to replace Ingress and service type load balancer and combine it to ones which is close to how container storage interface works.
Thanks. Sounds great.
Okay, we had a poll, and people are struggling a little bit with the deployment of the OpenStack cloud provider, as I can see here. Is there anyone who wants to elaborate on that?
I would say, at least for us at CERN, it's not a struggle. We just miss a Helm chart that it would be great if we have. And I think we have it in our backlog to contribute it, but if also others need it, we can all push together towards that. But this is mostly a comment, it's not a struggle. I don't know how you feel about having a Helm chart about it.
Would be totally fine. If that helps people. It's just the OpenStack part is going to go way out of Kubernetes core. So we need to have a way for people that they feel comfortable to deploy the new style of things. So and whatever works for you falls best.
Do you have another recommendation apart from the manifest and the Helm chart, or is there another idea about it?
Not really. So we even didn't thought about the Helm chart, but but Helm chart might be a good idea, especially if you're using already Helm, then we can create one, or we can have one in tree. There are also other options these days, like kept packages, but I think people can use what people are used to use Helm these days, and it would be a good idea to have that in tree, I think.
I think the autoscaler is trying to adopt the Helm chart as well from Helm's charts and into the tree.
Okay. So according to the container storage interface, I have just another point that plays a little bit into the theme of, do you have long-running clusters or more cattle clusters? That was also in the previous discussion, I think, because this might be interesting for people using long-term clusters and you want to update. Because in the future, as I mentioned, the code is going to go away, but especially for the volume provisioning part, Kubernetes created a CSI migration. So that means you still have your old API for creating, or your old storage class for creating volumes and maintaining volumes. But under the cover, the kube controller manager talks to the CSI plugin. And that is true for all cloud providers. It's not just specific to us. So I think people who run long-run clusters will need that feature in the future, so that you can still update your clusters, even if there is no Kubernetes, no OpenStack code in core Kubernetes, but you can still use all the old storage classes to be maintained.
I'm curious, roughly how's that going to work? Is there going to be kind of a mapping from, oh, you're using the in-tree Cinder one, you must be using CSI Cinder now? Is it that kind of thing?
The thing is, if you would like to migrate from the old one to the new one, and you just rotate out your old workloads, then you can happily just create a new storage class, make it as a default, and let it roll slowly. That's also possible.
Yeah.
So, but on the other hand, if you configure your Kubernetes and the controller manager and the kubelets to use the CSI migration, which is going to be on in the future, under the covers, the kube controller manager still answers for all the volume provision it knows about and it was programmed for, but it reaches out for the let's say Cinder CSI plugin in our case.
Okay.
You know, so the way is the old one, but the kube controller manager doesn't call the internal code, but it calls out for each of the other ones, and that's pretty great because it works for all the cloud providers.
That's neat.
And we just have one code path in Kubernetes core remaining.
So I have a dumb question. Suppose I have a PV provisioned by a sender in the cloud provider with the entry cloud provider. And I now upgrade, and I can still work with that old PV using the original APIs because of what you just described. However, the new API would be new capabilities such as snapshots and topology support, to pick two examples. Can I use the new APIs with the old PV that was originally provisioned, or is it only compatible with the old APIs, but I will not have the new capabilities for it?
Well,
I'm phrasing the question well.
Technically, I'm not quite sure, but maybe that works. So it could be possible because the CSI driver knows about the volumes.
Yeah, I guess
So
I'll ask it as an issue, and maybe unless Anusha wants to tell me right now too, but it's something I puzzled about. Is it will provide compatibility for the old PVs, but if I wanted to use the new APIs with the old PV, including new capabilities, and presumably the new APIs would work for the same old capabilities. Like I could destroy the PV with the new API. I found the doc a little bit ambiguous.
I'm not sure if the old APIs the underlying translation will work, because it is not yet supported in Intri. So will that actually work? I'm a bit doubtful on that.
It sounds like you would have to have a magically auto-created new thing in order to be able to edit with the new APIs, wouldn't you? Within the Kubernetes namespace, right? I guess that's what you would want.
Yeah, I mean, it struck me that it might be possible because sender snapshots have been a thing forever, and sender topology, on the OpenStack side have been there for some time. So it's not like they were invented for the new CSI capability. But I guess the safe thing to assume would be you keep using the old PVs with the old APIs, and it will continue to work. And your data copied over to some new PVs for the future someday, so you don't have to keep using the old stuff forever.
Yeah, I think you could also just rewrite the provisioner of the PVC you had before, but that's usually not a good idea to fiddle around with that too much. It does work. I did that, but it might destroy something. So
it does sound a bit data lossy, for want of a better adjective.
Yeah.
It's interesting because it is like it seems like a mirror of the long-lived versus short-lived thing. Because obviously all of these PV, well, certainly with the new API, right, we could actually we can have an existing Nova volume that has my special stuff in that I'm connecting again through the new API. But if you created it in the first place as like an ephemeral Nova volume, then you're a bit stuffed, I guess. I'm guessing
Yeah, it's a mirror, but in general, one wants the life cycle of volumes to be rather more stable than even clusters.
Yes, no, I think that's true. Yeah, because you'd want the multiple clusters. When you've got the second cluster coming up, it may want to use the same data volume, I guess, at least in the Manila sense.
In an ideal world where I've drunk all the Kool-Aid, I ought to be able to have short-lived clusters and nice YAML and persistent volumes, and be able to tear them down, not just scale them down to 0, save power, save money, and then come back next week and hook up to the same persistent volumes with the right YAML and just take off. Might be a little nervous about doing that sometimes, and people keep their clusters alive, but in theory.
I've seen that work with Manila for what it's worth. It works quite nicely with the SFS Manila
anyway,
stuff.
thanks.
So
Okay.
Yeah, we
Yeah,
have one question about the CSI migration. Does it feel ready now? So it is, it's in beta 1.17, so ideally it should work seamlessly. All yours should be migrated. So if anyone feels like anyone wants to share their experience about the CSI migration not going well or working well in your cluster.
I should probably own up because that question was me. I think I remember using it was either the Cinder one or the CephFS one, and I can't remember. I guess and maybe this is a question of me going to read the README on your repo, but is it clear which version of Kubernetes and which versions of cloud provider OpenStack means success with the CSI? That makes
A provider
maybe it's been working for ages.
Yeah, 1.18, I think we have moved to beta for 1.18. So we have all the jobs up and running, so it should work ideally. So
that was alpha before, wasn't it? Right. Okay, that's a good signal.
Is the deadline 1.22 or 1.21?
Yeah, it's 1.21 that will be entry will be removed. So it's suggested to migrate by that time.
Thank you.
And I see from the poll that there's a bit of challenges during upgrade. So I think upgrade as in with respect to which provider or any challenges with respect to that. Anyone would like to share on that? And yeah, deployment also feels like one of the issue that is being faced, I think 44%. So anyone would like to share what could be improved with respect to deployment, upgrade, or what issues?
Yeah, I came across some in the one Go, especially related to Go. It was because it has certain path 1.13 versus 1.14. There is a break there, and that was my observation.
So it's basically you have tried for Kubernetes upgradation or specifically for this project?
No, Kubernetes.
Kubernetes upgrade.
Are you talking about the Golang? Is it like the Golang upgrade you're talking about, or the Kubernetes upgrade?
Dependencies are there, right? So that makes it difficult to figure out, especially paths and where do they reside, and so maybe it was because of the path definition, but that was one which I faced directly. Struggled, but got over it finally.
So there is a change in using the dependency, like previously it used to be the dep and now it's go mode. So other than that, I don't think is there much. So you have faced with respect to using go mode because paths are not taken in with go mode, but it's required in dep dependencies.
Yeah, that's correct.
Yeah, it's a long time back, I think.
Yeah, that is because I had a old setup, so.
Yeah, it's done across all the projects in Kubernetes. So I think using a mod is much easier. So maybe once you have migrated, you find much easier to use it there.
Yeah, once we switched to mod, it became easier. Yeah, that's correct. But this was one of the observations.
Yeah, and I think it improved very much on the 1.17 release of Kubernetes when they decided to add the tag 017 so that we can use it directly. I think some of the confusion could also be that the dependencies before were kind of clumsy and just with the git char and 0.0.0 as the release number, and the Kubernetes team decided to go with the versioning. If we are at v1.18, we also have the tag 0.18, so we can depend on that, and go mod works. Maybe that struggle comes out of that time. Okay, I wanted to, maybe we skip to the last point because we just have 3 minutes to go. I lost my slide here. And I just wanted to know a little bit, or we wanted to know a little bit about contributing to the project. So if you would like to contribute, if you know where to go, if we can provide any assistance, because it would be great for us to have more people on the project, so that we create a good provider and a good environment for Kubernetes to run in, so on top of OpenStack for sure. Are there any thoughts about contributing?
You mean OpenStack provider?
Yeah, for the entire project. So like the CSI is, we do have all in one repo, what I mentioned so far. So we have the cloud provider manager, we have the CSI drivers that are also in tree, in the same tree.
So the one question which came about smooth attach and detach of volumes in the storage space, where you don't lose whatever you have, the older one, right? In PV especially. I would be interested in looking at that at least.
So I can provide a link to our repo if you like to.
Sure, go ahead.
Are there specific things that you as a team would like help with? No, you all as a team.
We need, when people don't want to contribute or can't contribute so far, we want to hear from people that are using the stuff, because it's interesting how people are using it and how people are struggling using it, because we are stepping forward all the time to not having OpenStack dependencies in Kubernetes anymore. And OpenStack, our team, we want to build a smooth environment for that. And we also want to be one of the good examples as cloud providers that are available for Kubernetes. So
yeah,
it would be
and
great
also,
if people, yeah, go ahead.
Yeah, we need help from documentation to testing, so we need all the help needed so we can increase testing, which is lacking in the project right now, and documentation also definitely can be improved in my opinion. So anyone could start at least on that, so that would be also much helpful.
I think to reiterate one of the points that was made earlier regarding simplifying the deployment. So more and more projects are moving to Helm charts, which are maintained by the projects themselves, because I think Helm, stable Helm repo, they're sort of trying to offload sort of lots of projects from their default repo. So a start would be to set up like a GitHub pages or something for OpenStack Cloud Controller Manager, which hosts Helm charts for all of the sub projects within OpenStack Cloud Controller Manager. So one for CSI Cinder and one for Manila, and also for OpenStack Controller Manager itself. So yeah, making the deployment easier would be quite a good start.
Yeah, I think there's already support for Cinders and Manila plugins. So yeah, for the OpenStack Cloud Controller Manager, yeah, it could be definitely added.
Yeah, I think the people with the right privileges would probably need to make a move on that part. So.
Yeah,
right, well,
that's a good point.
I hate to cut off a good conversation, but we are running close to the hour. So I just want to say thank you to all of our wonderful moderators and participants. Thank you all so much. I wanted to give you all a chance to just kind of give a quick summary of the 3 sessions just to kind of wrap up today's conversations and lead us into tomorrow. We had a bunch of polls that were really great to see responses on. It looked like about half of the participants were running containers in production, and then the other half were either developing, testing, evaluating. So we got to cover a wide range of experiences and technologies and implementations. So with that, I will let Spiros give a quick summary first. I think he's still around. Maybe John, do you want to go ahead and?
Cool. So I think there's some good conversations on how people are running OpenStack and Kubernetes together. It was interesting seeing from the poll, it's the mix that you're saying, right? There's a whole bunch of people doing it today in anger and a whole bunch of people trying to find out how to do it. So hopefully those dots can get joined. People get confidence from seeing lots of people doing it well. There was an interesting conversation, I think, between disposable clusters and long-lived clusters and how that changes how you use OpenStack and Kubernetes together. And lots of good talk at the end about inception-based testing, which is cool. Yeah, I think that was my main takeaways from that session.
Great. All right, I don't know.
John, could you also tell us which where you want the discussion on those topics to continue?
That's a good point, Thierry. Where do we want those discussions to continue?
I mean, at one point you mentioned the scientific SIG as one way to discuss the hardware acceleration enablement. Maybe that's a good way to discuss at least that aspect. But for the others, I feel like the Kubernetes SIG is also an interesting place to contribute.
No, I think that's a good point, Thierry. So yeah, definitely for those interested on the performance and accelerators between the Kubernetes and OpenStack working together thing, I think that's definitely a thing to take to the OpenStack SIG, and we should discuss that there. I think that makes sense. Sorry, my toddler is cutting ice. Too much watching Frozen. Anyway, so yeah, and I think one of the other things was a lot of talk about Magnum, and obviously the Magnum project has meetings and the mailing list to talk about those Magnum related things. That sounds good.
Great. Well, it looks like we have Spiros back now. Spiros, do you want to give us a quick rundown of your session?
Yeah, sure. So I think it's mostly because of the subjects that I chose that we went around all the supportive projects that you have when you run your applications, like the registry, CI, and one that we missed was monitoring, because these are essential components when you want to move something into production, because we as cloud team at CERN, we started moving some OpenStack services and some other services like Logstash, Rabbit, and others on Kubernetes and on containers. I think as we have the large SIG, the large scale SIG, the scientific SIG, and so on, in one of those SIGs, some knowledge would be interesting to go into, and also some iterations, I think, into how we release artifacts when we talk about containers, because for tarballs and RPMs and so on, all the processes are streamlined, but for containers, I think regarding security and provenance, we are still a bit behind. And I think, yeah, it's mostly just trying to collect the knowledge and put it somewhere for everyone to consume, and maybe we can focus on some use cases on how production deployments look like. This is not exactly something related to OpenStack, but as a big community, we can have some info there. I think the OpenStack Helm community tried to do something because they focus on running OpenStack on containers plus Kubernetes, but the basic unit, which is a container in a pod, it's valid for all projects. It's not only for Kubernetes. I think that's it. It's mostly discussion, I would say, and building documentation. That will be my 2 cents.
Yeah. Great. All right, and Anusha and Christoph.
Okay, I like the day very much. So there were interesting discussions because we tackled the entire problem from 3 different sides, like the application management as it on Kubernetes, which is a kind of unsolved problem if you have a look at some of the containers out there and the ways how the people inject stuff, how creative they are to inject stuff into their containers, so that they don't have the immutable infrastructure to get around the immutable infrastructure. And on the other hand, we talked about how Kubernetes comes on top of OpenStack, which was pretty interesting, and how we can use OpenStack to run Kubernetes on top of. And in the last session, we talked about how software running in the cluster can help to leverage OpenStack, like creating load balancers and so on. And that was a pretty great talk in all the 3 sessions. So thank you for inviting me.
Of course, I agree. Yes, great conversations. All right, well, then with that, we will see everyone tomorrow, same time, same place. And we'll be talking about telco and network function and security and isolation tomorrow, and then doing a little bit of a larger wrap up to talk about next steps. So thank you, everybody, and we'll see you tomorrow.
Thank you.
Thank you.
Yeah, thanks, everyone. Bye.
Yeah, thanks.